So until today, we had look on these collections. We discussed what is the collection. The collection comes from iterable, and then we discussed about list, and then we discussed about array list. We discussed about vector, and in the last session we discussed about stack. So in the future, we are going to talk after we discussed about linked list is that we're going to talk again about interfaces. So all this green, what you see is interfaces, and the gray color is the concrete classes. So we are going to discuss about linked list, which is again uh, implements a array list, and it also implements the interface DQ. So I was thinking that it would be appropriate if I discuss about linked list when we actually understand what is a queue and DQ. So once you understand these interfaces of queue and DQ, then understanding the linked list will be more easier because you have an idea of what is the DQ interface and the queue interface. So why don't we take an example of queue first, then DQ, and then come back to linked list? Seems to be a good idea. So that is what I'm thinking. So what you see now is a queue example, and this person is clearing the queue, right? The first in, first out. You see this, right? Uh, whoever stands in queue, right? This person stands last, so he gets cleared, after everybody's turn. So this is the person in queue, right? And he gets cleared. This is the person in the queue. He gets cleared after the count is processed. So this is called as a queue in real life. How exactly it happens? People stand in queue, and the first one will be first out, right? So this is the queue data structure what we are going to study today. So this is the structure of a queue, what you see. Uh, so what you have is, this is a queue, right? Where people start from the back, and then they get processed at the counter, and then they leave the counter. So whoever comes first gets served first, and then he leaves the queue. So first in person in the queue, the first person who goes out. This is known as FIFO, first in, first out data structure. So now what we see is we are going through the Java API interface queue. If you can see this, what you have as an interface queue, what are the methods it has? It's an interface, it extends collection, right? Uh, and it has methods to insert the method name is add, and then it has method to remove, which is remove, and just like peek, right, is the element, you can peek it. So these are the basic APIs, right? Today we will see the interface queue, but the very important thing to understand here is that you just can't take an interface and then implement or show something working right in Java. Somebody has to implement that interface, then only you can show that. So today we are going to see how exactly we do that. uh, let's come up with an example of what exactly queue is. Queue basic thing is it implements a FIFO data structure, that is first in first out, which I showed in the video before. How do you do that? How do you how does the elements look when you add to a FIFA structure? Let's see that. Okay, let's write a class and then let's name that class as Q example, Q U E U E Q example. Right, then let's write a public static void main. Now we have to see how to implement a queue, right? So let's say the queue is interface, and as we saw this, how do you declare the queue? Uh, Here, queue Java API went here, and then going to call the interface queue, right? Queue my queue Q Q Q E equals. Now I have to, as I discussed, that we need to have a concrete class on the left side. I'm going to say is new linked list. Let me correct the name of the queue here. I'm going to say this as Control V small q. This is my queue. And then I'm going to have a linked list. And then I'm going to have queue, right? So I have a queue now. Now I need to see what operations are there in this queue. So I need to add something to the queue, right? So what do I say? My queue dot add. Let's add some fruits. That's the most easiest way, right? Apple, apple, and then let's add banana, or let's add orange. And let's add mango. And these are the elements which I've added. What tells the operation is there here? So I used add an element. Then I can peek. Let's see if we can peek. First element. And then what I would do is my q dot element. What do you expect here now? What would be the output of this? Let's see if we can execute this program. Run as Java application. Proceed. Yes, we got Apple because Apple was added first, right? And that's why we got Apple as the first element. And if I do another peek, what happens? What do you expect? Second element. Let's see what is going to come here now. The second element is also Apple. So it always gives you, the element is always going to give you the first element in the queue, which is Apple. Now let's see, I'm going to remove this and then let's see what happens. My queue dot em, and then I'm going to see what is going to print now, what the remove operation is going to do. There you go. When I removed, then it showed me the orange. So we saw the usage of add and remove. We saw the usage of queue. We saw the concept of FIFO. We saw what is add, which is what is remove. And then we saw what is examine. So this is what we introduced the basic elements here. Let's see further. Now, one thing is that we saw element method, and what does peek do? Is there a method like peek, and what exactly it does? So we saw we removed the element, the first element, and then let's peek it. Instead of using element, I will use peek. Let's see what it is going to display. Let's see this as peeked element, then this makes more sense. And then let's run this. Yeah, so peeked element is orange. So we saw all the basic operations of a queue. And if you like this video, do subscribe.